All right, this is Advanced Math, Unit 4, Lesson 9. Analyzing trig graphs. Okay, number 1. Find 3 asymptotes for y equals tangent of 6x. Find 3 asymptotes for y equals tangent of 6x. Okay, so typically when we do tangent function we only find 2, but this one is asking for a third, so it will require a little extra work. Okay, amp, the fake amp is 1, which it really isn't important here because all I'm looking for is asymptotes. The period is pi, not 2 pi. Pi over b, which is 6, so pi over 6. And then we take and we cut that in half. Pi over 6 times 1/2 is pi over 12. So negative pi over 12 and positive pi over 12 are the start and end, which are 2 of our asymptotes. So we're more than halfway done. Okay, so I have negative pi over 12 and positive pi over 12. And that's 2 of the asymptotes. What's the length between negative pi over 12 and pi over 12? If you do right minus the left, you end up with 2 pi over 12, which is pi over 6, which makes sense because that is the period length. So there are asymptotes, and I did talk to you guys about this in notes. There are asymptotes in both in class. There are asymptotes in both directions, going to the right and going to the left. It doesn't matter which way you go. I am going to go to the right. I'm going to go out and find the next asymptote. You could go to the left if you'd like. Okay, and we did talk about this in class about how would I find this next asymptote. Well, we know the length here is pi over 6, so we would take pi over 6, add it to pi over 12 to find the next asymptote. Again, I would take the pi over 6, add it to the pi over 12 to find the next asymptote. So I'm going to do pi over 12 plus, I'm going to call that 2 pi over 12, recognizing that 2 pi over 12 is equivalent to pi over 6. And I'm going to add that together and I get 3 pi over 12, which reduces to pi over 4. So this one here is pi over 4. And those there, that's it. I'm done. I have my 3 asymptotes. Negative pi over 12 is one of them. Positive pi over 12 is another. And positive pi over 4 is the third. Again, if you wanted to, you could have done negative pi over 12 minus pi over 6 to get going in the other way. Okay, let's go ahead and continue. Number 2. For this function, y equals 3 sine 2x plus 1, A, what is the max? B, where does it occur? Okay, what is the max? Where does it occur? Okay, the what is the max you could probably do without any graphing, but where does it occur? You may need the graph. Some of you might be able to do without, but I'm going to graph just to get the practice anyway. And you need to have work for part B, whether if you didn't do a graph, then you'd have to show your algebraic work, which I will show you in just a bit for the next problem. Okay. So amp is 3. And I'm going to adjust that because there is a vertical shift. Okay, so there's a vertical shift of 1 fake axis, and then from there the amp is 3. 1, 2, 3, which would put me at 4. 1, 2, 3, 4, and then down 3. 1, 2, 3, which would put me at -2. So I'm going to oscillate between 4 and -2. So right there, without graphing, what is the max going to be? It's never going to get higher than 4. All right, where does it occur? Well, that we're going to have to sketch it out. Okay, it's positive. Period, what is the period? Period is 2 pi over b, so the period is pi. Pi cut in half is pi over 2. Pi over 2 cut in half is 1/4. 1/4, 2/4, this is going to be 3/4. 4/4 is indeed 1 pi. Okay, so it is regular sine so it's here, maximum, fake 0, minimum, fake 0. All right, so the maximum is 4. Where does it occur? It occurs at pi over 4. And again, the graph just gives you a little bit of practice with your sketching. Okay, next one, number 3. Where is a 0 for the function y equals cotangent of 2 parentheses x minus pi over 3? Where is a 0 for this function? Okay, I'm going to go ahead and graph. Amp is 1. Period is pi over 2. Pi over 2 because that's 2 there. Horizontal shift, set this equal to 0 and solve, you get pi over 3. Now cotangent is just like sine and cosine as far as your start and end goes, nothing special like the tangent graph. Start is your horizontal shift. Your end is your pi over 3, your start plus your period, pi over 2. Common denominator, go ahead and do that now. When you do it, you end up with 5 pi over 6. Okay, so we're going to go ahead and do that now. Start is pi over 3. 1 over 3, 2 over 3, 3 over 3, 4 over 3, 5 pi over 3, and nope, it's 5 pi over 6, so I'm going to start over. Okay, because I want this to end up counting out evenly, I'm going to change pi over 3 to have a common denominator with my end for a few reasons. 1, it's easier to space out. 2, when I'm adding and cutting in half, I need it to be a common denominator. So pi over 3 is equivalent to 2 pi over 6. Does everyone see that? 2 pi over 6 is pi over 3. So since they are equivalent fractions, I'm simply going to change pi over 3 to 2 pi over 6. And I'm going to put 5 pi over 6 out there. Okay, here are my asymptotes. And it's asking me for the 0, and I know enough to know that in my cotangent graph, the 0's right in the middle. So I don't have to worry about finding my quarter points, I just need to know about finding my middle. So I'm going to add these two and cut them in half. 5 plus 2 is 7, and 7 cut in half is 3.5 pi over 6. Now you're never going to see it that way on a test. They're not going to write it for you as 3.5 pi over 6. I'm okay if you write it that way if it's an open response, but if it's a multiple choice, how do you do it? You do what we did earlier. 2 plus 5 is 7. 7 pi over 6 times 1/2. Now what I've been doing is just cutting the top number in half, but mathematically correct, you times it by 1/2. 7 times 1 is 7 pi, 6 times 2 is 12. There is your answer. 3.5 pi over 6 I would accept, but you should know it is the same as 7 pi over 12. 3.5 pi over 6 is equivalent to 7 pi over 12. 7 pi over 12 is indeed your answer. I will show you in class tomorrow how to solve it algebraically. So this is how you solve it graphically. I will show you in class how to solve it algebraically. Some of you may like that way better, some of you may like this way better, but you do need to be aware there is more than one way. All right, that is it for now.